Good day everyone, I am Venice Guevara and I would like to show you how to solve mathematical problems involving patterns. Let us now start. A sequence is a list of numbers in order and each number is called a term. So given this sequence, let us find the next term. To find the next term in the given sequence, we are going to use the difference table. What are we going to do is to subtract the two numbers to find their difference. So 20 minus 11, the answer is 9. 36 minus 20, the answer is 16. 59 minus 36, the answer is 23. And 89 minus 59, the answer is 30. As we can see, the numbers are still not equal, so we need to find the second differences. So for second differences, 16 minus 9, the answer is 7. 23 minus 16, the answer is 7. And 30 minus 23, the answer is 7. Now that the numbers for second differences are all equal, and we also have the pattern, let us now proceed to get the next term for first differences. We're going to add 7 here. So 30 plus 7 is equals to 37. For us to be able to determine the next term in the given sequence, we're going to add 89 plus 37. So 89 plus 37 is 126. So based on Polya's method, the last step is to look back or review the solution or simply double check if our answer is correct. So 126 minus 89, the answer is 37. 37 minus 30 is equals to 7. Therefore, 11, 20, 36, 59, 89, the next term is 126. Next, we have the second example, which is 81, 100, 130, 180, 259, 376. So let's find the next term. Again, we're going to use the difference table. So for first difference, 100 minus 81, the answer is 19. 130 minus 100, the answer is 30. 180 minus 130, the answer is 50. 259 minus 180, the answer is 79. And 376 minus 259, the answer is 117. Since the number are not equal, we need to find the second differences. So 30 minus 19, the answer is 11. 50 minus 30, the answer is 20. 79 minus 50, the answer is 29. 117 minus 79, the answer is 38. Am I correct? Yeah. Okay, as we can see in the second differences, we still not get the equal number. So let us find the third differences. 20 minus 11, the answer is 9. 29 minus 20, the answer is 9. And 38 minus 29, the answer is 9. Since the number are all equal and we also have the pattern, let us determine the second differences. So we're going to add 9 here. So 38 plus 9 is equals to 47. So 117 plus 117 plus 47, the answer is 164. So for us to determine the next term, in the given sequence, let us add 376 plus 164. The answer is 540. So again, let us double check if our answer is correct. So 540 minus 376, the answer is 164. 164 minus 117, the answer is 47. And 47 minus 38, the answer is 9. So therefore, 81, 100, 130, 180, 259, 376. The next term is 540. Okay, let's move on, and now let's try to solve a problem using a Fibonacci sequence. The Fibonacci sequence is one of the most famous formulas in mathematics. Each number in sequence is the sum of the last two numbers. So the example of Fibonacci sequence is 1, 1, 2, 3, 5, 8, 13, 21, and so on and so forth. Each number in the sequence is the sum of the last two numbers. So 1 plus 1 is equals to 2, 2 plus 1 is equals to 3, 3 plus 2 is equals to 5, 5 plus 3 is equals to 8, 8 plus 5 is equals to 13, and 13 plus 8 is equals to 31. The formula for Fibonacci sequence is f of n is equals to f of n minus 1 plus f of n minus 2, where f of n is the number of the term, the f of n minus 1 is the previous term, and the f of 2 is the term before that. So now, using this formula, let us find the 15th term of the Fibonacci sequence. So we're going to find the 15th term. We're going to rewrite the formula. F of n is equals to f of n minus 1 plus f of n minus 2. Since we are finding for 15th term, let us substitute the 15 to n. So f of 15 is equals to f of 15 minus 1 plus f of 15 minus 2. So f of 15 is equals to f 15 minus 1 is equals to 14 plus f of 15 minus 2 is equals to 13. So f of 13. Our f of 14 is equals to 377 plus our f of 13 is equals to 233. Therefore, the 15th term of the Fibonacci sequence is equals to 610. What if we need to determine the higher term? Is there an easy way to solve the problem? Yes, there is an easy way to determine the higher term of Fibonacci sequence. What is it? We call it Binet's formula. Binet's formula is an explicit formula used to find the nth term of the Fibonacci sequence. It is so named because it was derived by mathematician Jacques Philippe Marie Binet, though it was already known by Abraham de Moivre. The formula of Binet is f of n is equals to 1 divided by square root of 5 times the quantity of 1 plus square root of 5 over 2 raised to n minus the quantity of 1 minus the square root of 5 over 2 raised to n. So since this is the formula, let us find the 15th term of the sequence. So just substitute the 15 to n. F of 15 is equals to 1 over square root of 5 times the quantity of 1 plus square root of 5 over 2 raised to 15 minus the quantity of 1 minus square root of 5 over 2 raised to 15. If you have the hyperscientific calculator, just put this formula and you will easily get the 15th term, which is 610. Next, visualize that we need to find the 30th term or the 30th term of the Fibonacci sequence. So using this formula, we can easily find the term. But what we're going to do is to substitute the number 30 to n. So f of 30 is equals to 1 over square root of 5 times the quantity of 1 plus square root of 5 over 2 raised to 30 minus the quantity of 1 minus square root of 5 over 2 raised to 30. So the answer that you will get is 832,040. That is all. Thank you for watching.